Well, welcome to our session today, migrating your data warehouses to Amazon Redshift. We're super excited. Hopefully you guys learned quite a bit over the last couple of days. I know today's sort of the last day, so thank you for coming this late in the conference. I'm joined by my colleagues. We'll just do a quick round of introductions. My name is Sandeep Brahmaratu. I am a global business development manager as part of our database analytics services organization, and I specifically work on our database and data warehouse migration program.
Thanks, Sandeep. Hi, everyone. I'm Ramya Kaushik. I'm a database engineer on the AWS Database Migration Service team. We own both the database migration service and the Schema conversion tool that can help you migrate your databases to the AWS cloud.
Yeah, hi, everybody. My name is Michael Su. I'm a colleague of Ramya's on the DMS and SCT service team, and I kind of specialize in data warehouse migration use cases.
Excellent. So I'll kick out the presentation today, followed by Ramya and Michael. We've got really exciting topics we want to cover with you. We'll start off just to set some context, just around some industry trends, what we're seeing from customers as to why they're looking to migrate off of legacy data warehouses. And then we'll dive into the migration aspects of it. Right? How are customers leveraging tools and techniques and best practices to migrate off of legacy data warehouses onto Redshift. That's where we'll spend bulk of our time today, including going into a demo that Michael will walk us over, where we'll do a migration of Netezza to Amazon Redshift. And then, as I mentioned, we'll do the best practices. We'll spend a fair amount of time for Q&A as well towards the end. So please collect your questions, and we're happy to kind of go through as they come along. Just a quick reminder, please remember to do the evaluation at the end. We do take those very seriously. We want to make sure that we continue to improve on our presentations, making sure that we've got the right level of content for you for future sessions. So this is a slide that we were asked to put in here. It's probably still relevant because there's still half a day's worth of re:Invent left. There's a variety of different sessions throughout this week. Some have already happened, both hands-on as well as breakout sessions like these, to really kind of get deeper onto our migration tools, tools that are used in database and data warehouse migrations, like Schema conversion tool, database migration service, and others. So highly encourage you to, if you have the opportunity to still attend some of these sessions, please do. So just some very high-level context as to what we're seeing in terms of why customers are migrating, right? What's sort of some of the drivers that sort of driving this movement from modernizing from legacy data warehouses to Amazon Redshift. If you look at the traditional data warehouse market, which has been around for the last 20, 30 years, right? Some of the common players you'll see in the space are folks like Teradata, Netezza, Oracle, Vertica, and others. And that's a fairly established market. A lot of enterprises today have their analytical needs served through these legacy platforms, right? Reporting, things like that. What we're seeing is as workloads are migrated over to the cloud, and customers are taking that opportunity to modernize their existing analytical and data pipelines. Right? They're wanting to leverage the best-of-breed technologies that are available to them. And as a result of that, we're seeing strong adoption of cloud-native data warehouses like Amazon Redshift. And that's really a very exciting time where customers are re-looking at their entire data pipelines and re-architecting them to really kind of get that best performance, scale, cost savings associated with cloud, which is what we'll touch on further today. Here's some additional pain points that we're seeing customers tell us in terms of what they're facing with their legacy data warehouses. As it comes to scale, right? These legacy data warehouses were built with certain sort of size and volume in mind. As volumes increase, as organizations are becoming more data-driven, depending on analytics to drive their businesses, some of these platforms are running into challenges from a scalability perspective. We see that come up a lot around performance and scale, which is also tied to a cost, right? As you add more capacity to these legacy platforms, they tend to be cost prohibitive. The variety of different analytical engines that have evolved over the last 5 or 10 years has really opened up a lot of opportunity for our customers to innovate on top of that, right? Things like Hadoop, Hive, Impala, Spark, Search, a lot of these newer frameworks that have come on board over the last 5 or 10 years is also highlighting the fact that these legacy data warehouses lack that flexibility in terms of running these modern frameworks and engines on top of their data and analyze it. Data formats is another big thing that we keep hearing from customers. Data is coming in a lot of different shapes and forms. Not having that support limits the ability for customers to query that kind of data and be able to get insights from both structured and sort of unstructured type of data. And all of this is leading to, again, with the data, implosion of data, right? The governance aspect. Organizations want to empower analysts and users, and as more and more users come online, right, how do you put the right governance model in place to be able to? So with cloud, we're seeing a fair amount of use cases that I'm sure some of these may resonate in this room, right? Across the board, lots of new use cases where data warehouses are being leveraged. Things like in the financial services, doing risk market analysis, both based on existing data, but also looking at more the real-time aspect of it as well. Healthcare, how do you improve patient experience based on clinical records and the data that pharmaceutical companies and healthcare companies are storing and processing and analyzing that data. Gaming, lots of log data to better improve ad targeting, things like that. The list kind of goes on, right? Based on which industry it is. This is very much sort of a horizontal play. So very exciting stuff. We're seeing across the board in terms of how customers are leveraging Amazon Redshift to serve these types of use cases. So that's sort of where Amazon Redshift comes into play. You may have heard Andy Jassy talk about some of the newer innovations that we've announced this week with Amazon Redshift, and at a very high level, right? It's this service has been around for a few years now, and it continues to be a very popular service on our platform. We've got over 10,000 customers today that have deployed and are actively leveraging Amazon Redshift for a variety of different analytical use cases. Performance is a very, very key component. It's something that we take very dearly, and that's something, some of the innovation that we talked about earlier this week with Andy's keynote highlights that, right? We're continuing to sort of ensure that is part of a key tenet of our roadmap. And today, if you just compare Amazon Redshift relative to some of the other cloud data warehouses, we continue to perform really well. A cost-effective nature of Amazon Redshift, both comparison to your legacy data warehouses on-prem, as well as other alternative data warehouses technologies on the cloud. Amazon continues to provide that in a variety of different options in terms of tiering, as well as we add newer instance types, we're able to provide more performance for you with these resources. Another big thing that we see with Amazon Redshift is the ability to integrate with the rest of the other Amazon ecosystem, right? Or even third-party ecosystem. The integration between the data lake technologies. A lot of customers use data warehouses in conjunction with data lakes, right? The ability to store lots of data and using that data for different types of use cases. So having that tight integration with S3, with Kinesis, with the QuickSight, with Glue, EMR, and all these different properties and services that we have is extremely critical because our customers are leveraging all these different services. Having a platform that is well integrated is a key component of how, a key benefit that our customers leverage with Amazon Redshift. And we want to help our customers minimize their risk, right? With data warehouses, these platforms have been around for a long time. There are a lot of existing processes our customers have in terms of reporting and things like the workflows. And we realize as you're migrating your legacy workloads to the cloud, that there is some risk involved. And there's a variety of different options that we have for our customers to be able to reduce that risk, right? In terms of moving that data, migrating the schema, the data, and make it as efficiently as possible. We'll touch on some of these things in our presentation today, but very quickly, right? As we kind of run from left to right here, Amazon or AWS Direct Connect, which is a service some of our enterprise customers use for that high-performance connectivity between on-prem data centers and AWS to help move that data faster. Snowball For a lot of, we see this happen with some of the large data warehouses where there's lots of data for a variety of different latency issues from a network perspective. They may actually want to ship that data on a Snowball, which is essentially kind of a device that looks about the size of a suitcase, right? You upload that data, ship it over to Amazon, and we're able to then upload that into S3 and take it from there, right? You have lots of options. AWS Database Migration Service, which is the one we'll talk about more deeply today, which is a very, very common way of how customers are migrating their data warehouses to AWS. Within Database Migration Service, there's a specific tool called the Schema Conversion tool that Ramya talked about, which is a very, very common pattern of how data is being migrated. So we'll dive into that in more detail. In addition to our own tooling, a lot of our customers have existing tools that they want to also leverage, right? Other ETL workflows and things like that. So we're investing pretty heavily. We have lots of great integrations and partnerships with a lot of tool vendors to help if customers do have a strong desire to use some of those tools, right? We do have support for those as well. For real time, lots of exciting use cases are happening on the IoT side, and customers leveraging things like Kinesis and other frameworks, right? So Kinesis is another great way we see a lot of our customers for that real-time IoT kind of streaming data coming in and having the ability to sort of query that data very quickly as it lands onto the Redshift platform. S3, faster way of getting the data transferred into S3 is another big common way, and there are other options there as well, right? So the purpose of this slide is you don't have to use every single one of these. There's one that might be more applicable to you. We'll touch on the AWS Database Migration Service and the Schema Conversion tool today in depth, including the demo, right? Which is a very, as I mentioned, is a very common way of how our customers are migrating legacy data warehouse data onto AWS.
Thanks, Sandeep. So I'm going to talk a little bit about Schema Conversion tool and how you can use Schema Conversion tool to actually migrate your data from your on-prem data warehouse to Amazon Redshift. But before I do that, I quickly wanted to differentiate what database migration service is and what Schema Conversion tool is. These are two separate tools that our team owns, and both are used for helping you to migrate, modernize, migrate, and replicate your databases. So by modernize, what I mean here is you must have heard this term a lot throughout reInvent. It's basically moving your on-prem databases to another database engine, which is probably more compatible for your application or which may work better with your application, or just changing your database engine. So just modernizing it. So Schema Conversion tool can help you modernize your databases by looking at your database schema, database code, your application code that has embedded SQL in it, and converting all of those into a format that's compatible with your target database engine. And by migrate and replicate kind of go hand in hand. What I mean by that is actually migrating your data. So Schema Conversion tool is used for converting your schemas. That's the first step. And then the second step is to actually do the data migration and move over all of your data from your data warehouses or your OLTP databases to AWS Cloud. Replicate is basically leveraging the power of CDC and keeping both the source and target in sync until the point where the latency is so low and your application is ready, and then you can do a cutover to the target database engine. So the difference between DMS and SCT is basically SCT is used for converting your schema, and DMS is for migration. There's one exception though, and that's what we're going to talk about in today's session. You can use SCT to migrate data off of your data warehouses, on-prem data warehouses, into Amazon Redshift by using another tool called SCT extractors. So that's the only place where SCT actually migrates your data. Otherwise, it's for any of the OLTP databases, it's used for converting your schemas and application code into your target compatible format. So another thing that I would like to just put it out there as you can use DMS to do the same thing. If your data warehouse is Oracle or SQL Server, you can use AWS DMS to migrate and keep your databases in sync with Amazon Redshift or a target database engine. But if you have databases that are Vertica, Netezza, Greenplum, or Teradata, then you would have to use SCT extractors to move your data completely into Amazon Redshift. And before I go ahead, has anyone used SCT or DMS at all? Quite a few people. Okay, so that means you've attempted database migration. So you kind of know what you're supposed to do before you actually do the data migration, right? You need to first figure out. You need to assess your application, your database. It could be a legacy database that has not changed for 20 years, and you might have to figure out which database engine should I actually move to? Should I move to Postgres, MySQL, or do I want to go to DynamoDB, just go to NoSQL, I don't really need RDBMS. So SCT can help you with that. So if you don't know which engine you want to go to, you can just connect to your source engine. It's as simple as connecting from your SQL Workbench. Just connect to it, run the conversion report, and it'll give you an assessment report, and gives you the percentages of conversion. So with Postgres, it can probably say 95% of your database objects were automatically converted. With MySQL, it could give a different number. So based on these numbers and the effort that you have to put in, you could figure out which database engine works best for you. So looking at that assessment, you could plan your migration. You can figure out what kind of skill sets you want, what kind of, how many hours or how many people you need to do the actual conversion. And it also helps you convert both the schema, database schema, including all the database objects, as well as the code embedded in your application, the database code or SQL statements embedded in your application code. It also helps you optimize, because you're going from on-prem, which has probably a lot of licensing costs, you could save some money by moving to AWS Cloud. And migrating to data warehouses, that's another aspect of schema conversion tool. Using extractors in conjunction with SCT can help you quickly and parallelly migrate all of your data from your on-prem databases to Amazon Redshift. So these are the main features of schema conversion tool. It generates an assessment report for both homogeneous and heterogeneous migrations. You may be wondering why you would use it for a homogeneous migration, because you could just do maybe a native data pump, or depending on your database engine. But the one cool feature about the homogeneous report is it creates a server-level assessment report, which looks at all your server-level objects. So it looks at your table spaces, users, your licensing, what kind of features you're using on your source database, and compares them with RDS. So this is available for both Oracle and SQL Server. So if you're using any features in your enterprise edition of Oracle, which are probably not present in RDS, Oracle, or the version that you're using, then that would highlight in the server-level assessment report. And like I've already said, you can convert your database schema, data warehouse schema, all the code. And you can also, if you want to use SSL, SCT is compatible with SSL. You could use SSL to connect to your sources and targets. One other thing is using the optimizing the schemas in Amazon Redshift. So if you're already in Amazon Redshift, but you've used it for a while, and maybe you find that the performance is not as good as it used to be before, you could run it again through schema conversion tool. It analyzes your tables, collects stats, and figures out what the best distribution key and sort key at this time for your table is. So you could either go ahead and apply that, or decide what is best for your application. But so schema conversion tool can be used for that as well. So this is the main tool that moves all of your data from your source database to your target. It basically works in, you have to create a task, and it does three things. It extracts, uploads, and copies the data over to Amazon Redshift. It's the extractors, basically are downloaded when you download SCT. There is a folder which is called extractors. All you have to do is copy that over to another host, which is in the same database, same network as your database engine. so that you have low latency with networks. And you have to run a shell script that would just install the extractors, then you configure it, and the next step is to register it with schema conversion tool. Once you do that, you create a task which would start extracting all of the data from your data warehouse using these local migration agents. All the data is then optimized for Amazon Redshift. It's saved into local files, and then it's pushed to S3 bucket or Snowball if you choose to use a Snowball, and then it's copied over to Amazon Redshift. So the way extractors are kind of optimized for full load. It is multi-threaded, fault-tolerant process. So every table has a single thread, and if your tables are partitioned, that's even better, because every partition has a thread working on it. So the more number of tables that are partitioned, it's faster to move it, and you can also use multiple extractors to extract data, and then, so it's a highly parallelized solution, which would grab all of your data from the source and then put it into Amazon Redshift. And just in case, because of whatever reason, if it fails at some point, you don't have to restart from the beginning. It starts from the point in time of failure, and then you can continue from there. So this is how the assessment report looks like. Once you connect, you can either just go ahead, and if you have complete confidence in the tool, you could just go ahead and apply all of the conversions to your target database, which most people won't do. Or you could download the report, which would look like this. And it gives you an idea of how many objects have been automatically converted, how many require a little bit of work. And if you see reds, it means it does require a lot of manual work. And on the right-hand side, you can see the details of each of the issues that it has highlighted. So why couldn't SCT convert it, what you could do to manually convert it, and it also gives you links to the documentation for maybe workarounds or more details about the features. For example, in this case, you see that the orange is for sequences, and it says it could not convert 100% of them. It's because there's no support for that in Amazon Redshift. So then you would see a link in detail saying there's no sequences, so maybe this could be a workaround. The migration playbooks, they actually go hand in hand with these reports. We have migration playbooks for Oracle, Amazon Aurora Postgres, and MySQL, and SQL Server. So what those do is they compare all the features on your source side, like Oracle and SQL Server, and compare it with everything on your target, like Amazon Aurora. And if there's no equivalent, these books were written based on our experience with customers. So it talks about any workarounds that could be done. It talks about if there's no exact feature, how else could you fix it? A quick example would be send email, which a lot of customers use in their SQL Server databases to automatically send emails from the database, which is not available in Aurora Postgres. So SCT has this functionality built in where if you could, if you enter your, if you create a profile, AWS profile with your access key and secret key, and let it create Lambda functions, it could emulate that function. It would create a Lambda function that would send an email from your Amazon Aurora Postgres database. So things like that, which may not be necessarily something that you would know just by reading the documentation, those things are highlighted in the playbook, and they also show up in the assessment report. So when you download, it's a client-side tool, so all you have to do is download it to your desktop. Once you download it and create a new project and connect to your source and target in this case, you will be able to see all your schemas on the left-hand side and your target schemas on the right-hand side. You can select as many schemas as you want and do the conversion. The only thing I would keep in mind if I'm converting a lot of schemas is to have a lot of memory. So if you have hundreds of schemas, I would definitely recommend downloading SCT on an EC2 machine, which has a lot of memory, and not your laptop or your desktop. Once you've converted and you've pushed everything to on the right-hand side, you could either apply it to the target, or you could save it in a SQL file. And in case you didn't like some conversion, and you thought that something else would work better for you, like data types, or if you wanted to change the name of some functions, you could just change it in your script and then run it on your target database. or if you have multiple databases, if you're going fanning out, you could use the same script in all the databases and don't have to do the conversion multiple times. One more cool thing about SCT is the changes kind of, we have a build out every month. So almost every month, we look at all the customer feedback that we get. We are really trying very hard to improve the conversion rate. We want to reach 100%. We are not there yet. But based on customer feedback, every month we release a build with all the fixes that go in. So if there's something that doesn't work for you today, it could work for you in the next build. And it'll be great if you can send us feedback, because that's how we can improve the conversion rates. We work with the development team and push it out every month. So before I go here, one example of the customer feedback is when we were doing the extractors. So by default, we grab all the data by doing a select star. But with the Netezza and Teradata, that was not working as well as other sources. So we decided to use fast export and external tables for those sources to optimize and improve the performance of the extracts, and basically speed up and improve the performance of the extract, load, and copy process. This is the Redshift table design that I was talking about before. You could use, if you're already on Redshift or if you're not too, you could use the screen to basically, again, reanalyze your database. Either use the metadata or use the stats and figure out what's the best distribution key and sort key for your tables are. So schema conversion tool also converts business logic. It looks at packages, stored procedures, functions, and application programs. For application programs, on the top you can see there's a button called applications. You'll have to go there and then click on new application, go to the folder which has all of your code. Right now there's no, you cannot give a GitHub link, which would just look at all your code, but it has to probably, you might have to like maybe check out the package on your desktop and then just give the folder link, and that will look at all the packages in your code and figure out what SQL needs to be converted to your target database. We also have something called extension packs. Since there's no equivalent, I mean, every function may not have an equivalent function in the target database. So we've created a bunch of functions which would kind of emulate this thing, those functions in the source database with the Amazon Redshift and increase your conversion rate. So this, the extension packs, basically, the first time you do a conversion, it creates a schema on your target database. It's called AWS_EXT_ the database that you're converting from. And it has all the functions there. You could, instead of calling the schema, you could embed all those functions into your code itself if you want to do the conversion and reduce the latency. But these get overwritten every time you download a new build. So if you're doing something in your own environment, it's possible it get overwritten. So you may have to just keep in mind when you're making changes. So migrating to Redshift, this is what we spoke about. This picture might help you visualize what I was talking about before. It's like once you download your extraction agents, set it up on a different machine, and then register it with SCT, all the data is then extracted to the S3 bucket. Once it's in the S3 bucket, it triggers compression, and once all the compression rules are in place, the data is saved into local files, pushed to S3, and then copied over to Redshift. So copy function is the fastest and most efficient way to copy to Redshift. So that's the reason we use that here. So this is kind of a similar picture, but it's a little bit more detail of how it differentiates from your on-prem side to your and your AWS cloud. Has anyone used Snowball at all? Okay. So it's a data transfer device. It's basically like a huge device which has a bunch of hard disks where you could store a lot of data. It's 100 terabytes in size. So if you have really huge databases and maybe poor network, you could consider using Snowball instead of just migrating everything on the network using an S3 bucket. So if you do use a Snowball, you have to You have to place an order for it. It'll be shipped to you in a day or two. Configure it, plug it into your network, and instead of the S3 bucket, you would have a Snowball Edge there. The extractors would then extract all of your data from the source database and put it in the Snowball Edge instead of the S3 bucket. So the Snowball Edge is also configured and partitioned as S3 bucket. So it kind of looks the same to you when you're doing the entire process, when you look at the SCT console. But it's going to the Snowball Edge. And once all the data is copied, you have to ship it back to the AWS data center. Once that's done, that will be copied over to Amazon Redshift. This is the summary of everything that I've been talking about. So if you start your conversion and data migration project, you have to first analyze it, then plan, then maybe develop your BI tools to write to both the targets, or if you could just stop it until the full load is done and then switch over to your target database and start writing to Redshift. Once you're completely off of it, then you can power off your current system. So next we'll see a demo that Mike is going to show about how to use these extractors to extract all of the data from Netezza and then move it to Amazon Redshift.
Yeah, so now that Ramya's walked you through like all the pieces that go into a data warehouse migration, we'll just show you a demo of using SCT and the extractors to actually perform that process. So these are things that you should watch for in the demo. We're going to go through a number of different steps. The first is we're going to set up SCT to perform the migration. Then we'll take a table from Netezza, convert it into Redshift and apply it on the Redshift database. Then we'll set up the SCT extractor so that it will do the data migration. And then we'll use parallel processing, like Ramya was describing, to migrate the table. And then we'll migrate the table, and you can see how you can use the tool to monitor the migration process as it's running. I'm going to skip a couple of things. I'm not going to show you how to install the tools, where you get the downloads and all that kind of stuff from. But there's a little bit of planning that goes on before this. So let's start by looking at our source database. This is a Netezza client, and I'm just going to go ahead and query one of the tables. It's a test4 table. That's the one we're going to migrate. It has about 33 million rows in it. So remember that number. So now we're going to set up SCT. And the process is really just creating what we call a project. And that project names your source and your target. You're saying you're doing a data warehouse migration. And we're going from Netezza to Amazon Redshift. So now that our project is now set up, we're going to connect to the source. And that's really just telling the tool where the Netezza database is and logging credentials. And then we'll do the same thing on the target. So server, port, logging credentials for Redshift, and now SCT is connecting itself to the Redshift database. So now that we have a source and a target connected to SCT, you can see on the left-hand side of the screen, SCT is populating a source tree. So we'll just go ahead and navigate through that source tree till we find the table that we're going to migrate. And it's called test4, and there it is. And now we're going to convert it. So when you click on the table, you can see the DDL that's retrieved from the source. And we're just going to go ahead and right-click on that table, and it will then convert the create table statement into an equivalent Redshift create table statement. And now we're just going to go ahead and apply that table onto the Redshift database. So it's actually creating the table onto the Redshift cluster now. And there it is. So now the next step is we have an extractor, we have SCT. We're going to set up the communication channel between them. And this process is called registering the extractor. So I'm going to click this button that says register, and it's simply telling SCT, here's a server, here's a port that the extractor is listening on. You give it a name. I gave it a generic name. This happens to be running on localhost and a port. And if you wanted to, you could use SSL to encrypt the communication between the extractor and SCT. So now SCT has registered the extractor. So now we're going to set up to use parallel processing. And this is called virtual partitions. So here's our table, test 4. We're going to basically take the table and divide it into chunks that will be migrated in parallel. So I'm a little lazy. You could type in the values that you want to use to divide the ranges. I've already done that, saved them into a file on disk, and I'm just going to import that file into the tool. And now there's the file, just basically a CSV file, and now you can check the ranges of the values that are created. So there's 33 different chunks here, all about 1 million rows apiece. Okay, so now let's go ahead and migrate the data. And this process is just creating what we call a migration task that includes the table as part of its scope. So we give the task a name. We say we're going to upload, extract, upload, and copy, which means all the way up to Amazon Redshift. We create the task, and then we'll start it. And you can see there's 3 phases here, like Ramya was describing. That extract phase, the upload to S3, and then the copy into Redshift. So now this is the really exciting part where we get to see yellow bars get bigger and bigger. You can see at the bottom, there's a number of, we call them subtasks that are created, each for one of the partitions or ranges or chunks that we created in that virtual partitioning process. So now the extract is progressing, the upload to S3 is progressing, and you can see that as an extract finishes, that upload process takes off, right? So it's keeping all of your possible threads as busy as possible, as long as you have remaining work to complete. And again, as Ramya was saying, behind the scenes, this is a Netezza source. The extractor is using the native Netezza export mechanism, which is Netezza external tables, to pull the data out from the Netezza database. So now the extract and the upload process is done. We're just waiting for the copies to complete into the Redshift database. And you can tell, again, you can see the subtask as a complete. So this is basically the console for SCT that you can use to monitor your migrations. We also have very detailed logging that's created for both the Redshift, that's created for both the SCT and the extractors that you can use to monitor and troubleshoot with. So in a few minutes later, it's all done. And if we look at the Redshift side of the Redshift target, we'll go ahead and query the test4 table that was created over there. And we should see 33.5 million rows, just like we had on the source. So all the data was migrated successfully. Okay. So that, in a nutshell, is what this whole migration process looks like using SCT and the SCT extractors. So, just to recap what we just saw, we did a migration of a table from Netezza to Redshift, including changing or converting the table schema into a Redshift table. We set up parallel processing to migrate the table in parallel, and we did it in 33 chunks using virtual partitioning. And we'll talk more about that in a little bit. And then we looked at how you can use the console to monitor your migration. Okay, so What I'd like to do for just a few minutes is talk to you about some best practices that you can apply as you start your data warehouse migration journey. These best practices are applicable to Netezza migrations like we just saw, but really to all of the data warehouse sources that Ramya described to you earlier. So, first and foremost, performance tuning, right? SCT and the extractors give you a number of ways to tune your performance. Your existing data warehouses, they have a lot of data in them, right? Terabytes of data, maybe petabytes of data with years of history, many different subject areas. You can, and typically your data warehouses are going to be tuned for extracting large amounts of data or analyzing large amounts of data. So you can leverage that with the extractors by dialing up or dialing down the fetch sizes that the extractors use. Another thing that the extractors do that's really very helpful is prior to uploading to S3 or sending it to either S3 or AWS Snowball, they compress the data files, right? And obviously the benefit there is a performance gain, but also it benefits you as a customer because it reduces your ingestion cost into AWS. The other thing that you can do with the extractors is adjust the file size that you're sending to the downstream systems. So Amazon S3, AWS Snowball, Amazon Redshift, all of those services are tuned to better perform with large file sizes, right? So you can increase that file size that the extractors are producing before they send them downstream, again, depending on your resources, what your network bandwidth is, and so on and so forth. And then the last thing is, and we kind of talked about that, actually I didn't talk about it, and I apologize. For each of the extractors has a number of threads that it opens against the source database. By default, that number is 10. You can dial that number up or dial that number down. Again, depending on your particular resources, how much resource you can devote to your migration process. So just a couple of words about virtual partitioning. Again, we saw that in the demo about how to make these chunks that we can migrate in parallel. There's just a couple of takeaways I want you to know about virtual partitioning. This is a really great feature and helps a lot of our customers. You want to apply it to tables in your database that are not natively partitioned, right? There is a tendency when we first talk about it with customers to say, well, I should just really partition the heck out of this table. And the guidance is usually resist that urge because as you can see from this graph, you can find a really good partitioning without a lot of effort and at fairly low granularities. And in fact, if you sort of over-partition, you're going to pay a bit of a penalty because of the maintenance of maintaining those extra partitions. On the other hand, if you have tables which are natively partitioned in your database, so for example, if you have a fact table that contains customer orders, say, those kinds of tables are typically partitioned by date, maybe range partitioned over time. You can use SCT to migrate those tables in parallel as well. It's basically a checkbox called the Union All view. You check that box, and then when you start your migration task, SCT realizes from the table metadata that the table is partitioned, and it will migrate those partitions migrate that table on a partition basis. We talked a little bit just a few minutes ago about sort of scaling up or scaling down the parallelism for a single extractor, well, you can also scale out extractors. So you can have many extractor hosts running many extractor instances, and really run your migration massively parallel. We have many customers who have done exactly that. You can have, there's really a wide variety of configurations that you can do here, depending on the resources that, again, you have available for your extractor hosts, as well as how much load you can place on your source system to support the migration process. So then at the, let's say we get to the end of your migration journey, your Redshift database is up and running, ETL is running against it, your users are analyzing data being served by the Redshift database. Is there anything else that SCT can do for you at this point? And the answer is actually yes. You can use SCT to analyze the workload that's running on your Amazon Redshift database. And based on that workload, it will suggest whether there's a better table design for some of your tables. Right? So in other words, if there's a distribution key or a sort key that better matches the workload you're actually running against your database, so that you could go and reorganize your table layouts to be more performant. And the tool will actually rebuild your tables on the fly if you choose to do that, or you can export a script and run that rebuild at a later time. So those are just some best practices we wanted to share with you. There are, as you begin your migration journey, there's lots of great information on the AWS public website that you can use. All of our technical documentation is there. You can go and just view it. The AWS SCT tool and the extractors, like Ramya was saying, is a no-cost download. You can just go to the AWS website, download the tools, install them locally, and start to see how they work. We also have some very active support forums where you can ask questions, participate in conversations with other customers, and the service team, we participate as well. So it's a great place to get information. So we'll open up the floor to questions. I just want to say that there's also some training and certification, again, sort of free courses that you can take to learn more about our database offerings here at AWS. Just a minute, sir. And also database certification. So thank you. Again, we'll take questions in a second. I just want to, again, remind you, could you please, we really would appreciate it if you would take the time to give us feedback on this session to make sure that we want to deliver the content that helps you in your migration journeys and improve if we can do that. So, yes, sir. ETL vendors?
Yeah, so we work with a variety of different ETL vendors, Informatica and other ETL providers that do support Redshift as a target, right? Especially if you're migrating. I think maybe if you can talk a little bit about the SCT and how we support BTEC and some of the other capabilities, that might be helpful.
Yeah, SCT can help you convert all of the ETL jobs into AWS Glue. So yeah, that's something that could help with your journey.
Yeah, and there's a very right. There's some, depending on your use case, right? Which legacy platform you're moving off of. There's a variety of different support that we can provide via SCT for that.
Yep.
During the demonstration, did you use DMS in the background or only SCT and no DMS?
That was purely SCT. SCT and the SCT extractors. So,
What are the difference if we use the DMS
So the question is, what's... Right. Yeah, so the question is, what is the difference between SCT and sorry, what is the difference between DMS and the SCT extractors? It's really an architectural decision that we've made, right? So for data, and the way I like to explain it to customers is DMS is a managed service, right? It runs within AWS. The extractors are an application that you install locally near your data warehouse, because you're going to be pulling massive amounts of data out of your data warehouse as part of this migration process. So having that logic close to your warehouse is a more performant architecture. And then again, we talked about sort of the compression of the files and all that stuff, right? So rather than shipping, if let's say you have a 100 terabyte data warehouse that you're migrating, you pull 100 terabytes out locally, right, with the extractors, compress that into something smaller before you send it up to AWS. And that's really the reason why.
And the extractors do incremental stuff? So I imagine what I can see happening is load data and then try to fix store procedure. I'm trying to see.
Yeah.
Yeah, the extractors they do only full load. They don't do the CDC stuff. But if you were using a Snowball, there's another agent called DMS agent that would do both full load and CDC. But with these sources and targets with extractors, it's just full load, straight one time.
I have two questions. As far as targets, from what I was looking at the docs, Redshift is the only target. Is there a plan to expand it to other targets within the AWS world? Or?
So for the stuff that we demoed,
For SCT, yeah.
so SCT supports many targets, right? Besides Redshift. In terms of like data migration, right, which is, migrating a data warehouse, the SCT extractors support Redshift as a target only.
Okay.
Now
Is there a plan to add more so you could use like Athena or something like that by just dropping it to Parquet and S3 or something like that?
Yeah, I mean, honestly, like our roadmap is 90% driven by customer requests and customer feedback. So if there are, other sources that you're interested in migrating from, contact your systems architect, your TAM, let them know, and that's how we really drive our pipeline.
And then my other question is, the metadata that's discovered by SCT, is that then useful for driving DMS, or are they two completely separate things?
No, they're two completely separate things as of today. Yeah.
Regarding the source, do you support any version of a wrapper, or do you have a list of the...
Yeah, we support 12 different sources and 14 different targets, and the versions are different for all these sources and targets, and it's there in our documentation. For Oracle, I think we support anything greater than 9i, like from 10G. So the SCT, the question is, what's the difference between SCT extractor and Redshift advisor? So SCT extractor does not do the Redshift sort key and distribution key analysis. It's the SCT itself which does it. Redshift advisor is probably more detailed. It is made for Redshift, but this is just an add-on if you kind of see that there's some performance issue, and if you wanted to analyze, this can also help with that. They're two separate tools, but if you wish to use Redshift Advisor and it's giving you the inputs that you require, you don't need to use SCT.
Yes, sir.
What do you see people do when they want to scale out their extractor hosts? I mean, I got to plan for that hardware in a big center. Any guidelines on what type of hardware or how much hardware I need based on size of data or local storage, that kind of thing?
Yeah, I mean, there's a number of tuning considerations there, and it's hard to say without having some more detailed information about your particular use case. But if you think about the way that the extractors work, right, they try to use memory as much as possible. they're writing and reading and compressing and then sending files up to the downstream process, right? So disk and disk speed is very important because it's writing massive amounts of data to your disk, reading it back, compressing it. And then you also have that flexibility of if you have a lot of resource for that extractor host, you can throw 1, 2, 3 until you consume what's there, right? So those are sort of some of the considerations. We can help you if you work with your local account team. We can help you tune your particular environment if you reach out to us.
My question is that with your experience with existing, let's say, client migration, customer migration from on-premises to your service, do you have some sort of statistics? How much have the migrate customers saved compared to the previous on-premises solution?
Maybe you're the best.
Yeah, again, it varies dramatically, right? A lot of times, the licensing on the source data warehousing, it really does vary depending on the vendor pretty dramatically. So I don't have like a specific answer. What I will tell you is that most customers see a fair amount of cost savings, right? Migrating off of a legacy data warehouse to Redshift. If you want the specific numbers, I could probably, with examples, I can follow up with you.
I was wondering, just a rough average or something like that.
Yeah. Sorry, I don't have that top of my head right now, but I can follow up with you on it.
There are a few customer use cases that are on the DMS resource page where some of them talk about cost savings, because not all customers are public with how much they save. The information is not, we are not supposed to give it out, but there are a few testimonials on the website. Maybe that could answer your question.
Yep. Fair question. Yes?
So when you do the Snowball load, how do you handle the change data capture and the final sync up of your data warehouse? I think we saw.
Yeah, so the example you saw was, we call it full load, right? Just basically taking a copy of your source and putting it into Redshift, right? Either via the Snowball or via S3. Right. What most customers do was sort of represented by that migration timeline slide that Ramya showed, which involves migrating some data, taking the ETL that you're executing to on your source to keep that source up to date, bifurcating it so that it also runs against Redshift, right? So customers, and it's hard to say because customers, I've seen it done both ways. Some do hey, I'm going to do a big bang. I'm going to take my entire database, throw it over on Redshift in one fell swoop, move all my ETL over, right? Start replaying the ETL that might have fallen behind. Some customers do it by subject area. Maybe you do orders first and then inventory and then, so there's really a wide variety of things, but that's typically the migration pattern that we see.
So to add to Mike's answer, we have not covered the DMS agent in this session, the one that does full load and CDC, because that would probably require another session of its own. That uses a completely different agent called DMS agent, which creates both a local task as well as a remote task. The remote task actually uses DMS to do the CDC, captures all the changes on the source, while the local task is doing the extraction and pushing it to S3. So that's as simple as I can get about it. I love such questions because I don't have an answer to it.
I'm sorry. Can you repeat the question one more time?
The question is, if you have a 100 terabyte database, how long does it take to migrate using extractors?
Yeah, it's a really hard question to ask because there's so many variables that go into that that are going to be unique to your database, your environment, your network, but you know, if you want to, if you're starting a migration journey, I would suggest reach out to your local account team. They can get us involved, and then we can help you with those questions and do that estimation with you.
So what's the shortest time you see that?
So the question is, what's the shortest time? There's actually a really great blog on the AWS blogs where a customer moved, what was it, 30 terabytes? No, it was more than that. But they had a very compressed time frame to do it. And they had to use just massive amounts of parallelization. So they had like 24 extractors, I think, that they were using in order to fit their migration into like a 30-hour window. So those things are possible, right? They take a lot of planning. They take a lot of experimentation to make sure that you're getting the throughput you think you're getting, or if you're bottlenecking, where that bottleneck might be and how you alleviate it. But it's all possible.
Can you repeat the question, sorry? So with MySQL?
So you know, like MySQL has like built-in functions and like different join types, and they're not necessarily the same as other.
Right.
Like, do we have to update our queries to reflect a certain standard?
So that's what SCT will do for you. So it'll look at all that code and try to find an equivalent function in Redshift. And if it can't, it might look at the extension packs and see if we have some way of emulating that function, and it converts that code for you. So if it's not able to do it, then in the issues, it actually writes the details of why it couldn't do it and what you could do to work around it.
So from demo line, it's giving impressions of one-time ingestion. So is there a way to do a continuous replication, spanning across days or weeks?
And do you want to go, what's your source and target?
Source is, I mean, like, say like this, because I don't want to stop the ingestion to the old source. So,
Okay.
yeah, because, you know, the downstream, upstream may not be ready.
So if your sources are Teradata, Vertica, Greenplum, and Netezza, then SCT extractors only supports full load. But if you have any other sources, you can use DMS to do full load and CDC. It will do the continuous replication. If you're using Oracle or SQL Server as your source, it can do both CDC and full load. And there's a bunch of other sources too that DMS supports. Or if you're using Snowball, there's another agent called DMS agent that you could use to do the full load and CDC. But for these 4 data warehouses, usually data warehouses are really huge, and you have jobs that you could run on your targets once the full load is done. So we've seen that customers just do the full load and move their jobs to rerun them on the target to catch up with what was happening on the source. So if it's anything other than these sources, DMS will help you with keeping both of them in sync.
So 2 questions actually. One is regarding the CDC, right? Does it use any like Oracle as a log manager, scrapes the logs and pushes that?
Yes, with Oracle, there's a bunch of different methods that we use. Log miner is the default method. It looks at the transaction logs for CDC, for full load, not for full load, but for CDC and replication. It looks at the transaction logs and pushes. So DMS is basically a logical replication tool. So it looks at, for any of the sources, it would look at the transaction logs.
Second question, so with the changes coming into Redshift, like with the coming in storage, is there anything going to change with this? So
Changes going into Redshift.
I thought there was an announcement that Redshift, they're actually going to be separating the SSD with the storage and compute, separate it out?
I don't think it should change with SCT, because what SCT is going to do is just, you give the Redshift instance as your target, right? Whatever instance you give it as a target, it's going to push everything to it. So it doesn't matter if you're using a storage or it could probably affect the performance, I think, depending on what kind of Redshift node you use, but.
Yeah, I mean, SCT is operating at a schema level, right? And I don't believe that's going to change in terms of like when the hardware separates between the compute and the storage. So.
As part of migration plan, you mentioned that to modify the ETL point of the new target. Is there any function in SCT which can make sure that okay, both targets are consistent? There could be some differences.
Consistence in schemas, you mean? Or
Like in the data, in terms of data.
data, not with
Not with
extractors, not with SCT. But DMS does that. It has a feature called DMS validation, which would validate your data row by row on the source and target, but not for these 4 sources with extractors.
Another question I have, like quickly ask, you mentioned that SCT can also help you to convert your ETL code retaining the informatically glue or something.
ETL jobs, it can help you convert it to glue. SCT can do that conversion. Yeah.
Today it's the Teradata BTEX and Oracle ODI, but we have others on the roadmap. The specific capability I was referring to is today it supports the Teradata BTEX and ODI on the Oracle side.
PL SQL, yes, yeah. It's part of the schema, database schema conversion.
By the way, and there are also other third-party ETL tools that you can leverage. But
Thank you very much, everybody. If you have any additional questions,
yeah,
we'll
feel
be
free to.
around. Yeah.
Thank you.
Thank you.